like this. Or, could be anything, but this is an example. This was called what kind of function? Exponential, right? Okay. When you work with exponential functions or equations, the graph is typically, okay, let's talk. 5, let's put a number in for x, like what? What's a good number to put in?
2.
2? Okay. If you put a 2 in, what do you get? 5 squared.
25.
25. You're up here. Okay, so 2 gets you 25. What does 1 get you? 5. What does 0 get you? 1. And that's how it looked. It was called exponential what? That's growth. Okay. But as you move this way, does it cross that x-axis? No. It did what? Rides out on the x-axis. That's called the horizontal what? Asymptote of what? Not x. Y equals 0. Okay? You guys, the x-axis, you know why they call it y equals 0? Because this is what? 2 comma what? 0. What's this? 5 comma what?
0.
Every point on the x-axis has a y value of what?
0.
That's why they call it y equals 0. Yeah? Okay. Anyways, that was yesterday. So, when you talk about functions, you always kind of want to know, does a function have an inverse? How do you check to see if it has an inverse? What test? There was a test. The horizontal line test said if you draw a horizontal line and you hit it how many times? Once, once, once. And I know here it might look like you hit it over and over, but this thing is constantly going which way? It's constantly going down. It's getting closer and closer to the x-axis, but it's not going to touch, and it keeps getting closer. But if you keep drawing the horizontal lines, you hit it what? You hit it once. So does it have an inverse? Is there an inverse to this? By the horizontal line test, you'd have to say what?
Yes.
Yes. And you know what it is? They call it the logarithmic function. And now, section 3.2, guess what it's about? Logarithms. Okay. So, yes, today you're going to take that function and you're going to use the inverse function, logarithms. Okay? Okay. So here we go. This is where we start with the definition. That's all it is, just definition. So what is a logarithmic function with base what? Base A. What is it? What says here? If you're going to take the log of a number, by the way, here's the log back here. If I'm going to take the log of x, x has to be what? What's another way to say greater than 0? Positive. There you go. So if I say greater than 0, what I'm really saying to you is x has to be positive. Okay, you see that number down there? That's called the base. Your base has to be what? Positive. That's what greater than 0 means. So this number has to be positive. This number has to be positive, right? But the base down here, guys, can't be what? Can't be 1. Because if it was 1, it would not form a log graph, which you will see later, not now. Okay? So this is what it says. Here is how you see a log problem. Y equals log base A of x. That's how you read that. Y equals log base A of x. If and only if, this is only true, if and only if this is true right here. This is called exponential. This is what you guys did yesterday. Okay, so let's kind of look at this exponential. This one says A raise it to what? The y power must equal what? X. Now go back there, because this and this say exactly the same thing. So if you look at a log problem, I'm going to come down here now. See how it says A raise it to the y? Here's your A. This is your base. You're supposed to raise it to the y. Where's the y on this problem? Where's y? This is y, yep. So A, raise it to the what? y power must equal what? X. So here's what you have to know. You have to know this. If you're taking the log of a number x base a over here, that's the answer. It's y. But wait a minute. Y is a what? And y is an exponent. So every time you do a log problem, guys, you're getting what? You're getting an exponent. And that's really, that's all a log is. It's an exponent. So you ready? I'll throw one at you. How about if I give you this? What's log of 25? Base 5. Oh, geez, you got that so quick. You said 2. How do you know it's 2? Because 5 raised to the what? 5 raised to the second power. Isn't that what? 25. And that's the way you read the log problem. You say base raised to the power of 2 is this number, 25. That make sense? Yeah? Okay, so if that makes sense, then this should be so easy for you. What is, let's do this. Log 10 of 1,000. Log base 10 of 1,000. Which is asking you for what here? What's it asking for? It's asking you for an exponent. What is it? 3? Yeah? What's 10 times 10? 100 times 10. 1,000. It's 10 to the what? 10 to the third equals what? 1,000. That's what a log is. Okay. And what it turns out to be, guys, is logarithms and exponential functions, they actually turn out to be inverses of each other. They undo each other. And you'll see as we go that they undo each other. Okay? All right, go here. I'm not asking you to give me an answer. I'm asking you to rewrite this equation. And by the way, this is a log equation. Rewrite it as what? An exponential equation, okay? So do what you saw in 3-1. Well, I'm going to let you do it now. I'm not going to do it. You're going to do it. Look at that. Translate that to that. And you're going to say what, Brandon? 2 to the third equals 8 is what Brandon says. Is Brandon right? Take the base. Raise it to what? The exponent out there. And you should get this. Is he right? Yeah. Hey guys, doesn't it make sense? 2 times 2 times 2 is 8. He got it. If you put the numbers in the wrong spot, just check your work. I don't think you're right. Okay? Check your work. Okay, do it again. Change it to exponential from here to here. I think you've probably already done it. Emma, you have it? No? Sophie?
8 of the 4 equals 16.
So, yep, if you look at the log, you know this is the base. If this is the base, you raise it to the answer. The answer is what? The answer is an exponent. A, raise it to the what? 4th happens to be what? 16. There you go. And what I'm trying to say is this log equation is exactly the same as this exponential equation. They're exactly the same. So if I made a table of values, I mean, I could graph this, I could graph this, I'd get the same graph. Now, why am I showing you it both ways? Because it's easier to graph. Which one? This one. It's easier to graph exponential. And that's why you kind of want to know, how do I get out of this log form? I don't really want to graph a log, because you're going to graph it in the end. You're going to want to go from here to here, or here to here. You'll see. Are you okay? Do it again. Except this time, I'm giving you what equation? Exponential. Change it to what? Logarithmic. You need the word log in your equation, just so you know. Katie, what do you think about this one from here to here?
Log 3
Okay, log 3.
no, sorry.
Log what?
I forgot how to say it, but I have.
You always say log base. What base do you want? Which one's the base up here?
3.
Yeah, 3 is the base.
Yeah.
So you'd say log base 3
Okay.
of
81.
of what? 81
equals 4.
equals 4. Yeah? Well, look at this, guys. It says 3, raise it to the what? 4th. Well, does she say 3, raise it to the 4th? Yep, yep. And that gives you what? 81. Well, in this case, it goes this way. Does 3 to the 4th give you 81? Yeah. I mean, now I know it's right. I just make a little circle when I see these logs and go, oh, 3 to the 4th gives 81. It does. Okay, that one, Cassie, is what?
Log base 4.
Log. She says base 4 of
Log
what?
64.
Of 64 equals x. When she says log base 4, I want to know 4 to what power? 4 to the x power equals 64. Does that make sense? I'm just converting back and forth. That's all I was doing. I wasn't really solving anything. I was just saying this is the same as this, and then I did it the other way. You okay? Okay. Ooh. You see that? Look at your what? Yeah, your properties on page 228. And last hour I just went over them, so I'll just go over them again. We don't have to look. Let's just do it. Okay, there are 4 properties. Here they come. 1, 2. Number 1 says this. If you say log of any base, A, and you put a 1 out here, I mean, on page 228, they'll tell you the answer, but let's think about it. What's log of 1, base A? A what?
A to the power 0.
So you're saying the answer is what?
0.
0. Is he right? A, raise it to what? A, raise it to the 0. Is it 1? Yeah? Okay. So you know what it's really saying? If you take the log of 1 and you have any base here, the answer is always what? 0. So if I did this to you, log of 1 base 3, what's the answer? 0. How about log of 1 base 7? 0, right? 3 to the 0 is 1. 7 to the 0 is 1. So basically log of 1 is what? 0. That's it. That's a property. All right, next. Log of A base A. What's the answer? What? Zach says 1. You think it is? A to the what? First is what? A, is that true? Yeah. Okay. So what this property says, I hope you kind of jot these down over the side, is log of, let's say, 6 base 6 will always be what? 1, right? Log of 12 base 12 is 1, right? That's all it's saying. Okay? 3. 3 is a mess. Here we go. Log of A base A looks the same, doesn't it? Log base A of A. But A is raised to the what? To the x. What's the answer?
X.
X? So you're telling me if I do this, A to the what? A to the x, right? You're telling me put an x here. A to the x right here equals what? a to the x. Is that true? Yeah. Okay. Now think about it, guys. Go back here. Go back to this one. Log of a base a. What's the power right here? 1. Was the answer 1? I forgot to put it, but yeah, it was 1. Okay. But now they're saying log of a base a, the answer will always be that number. That whatever that exponent is, it's right there. So guys, you know what's happening here? You have log base a, and now you have, look right there, just right there. That's exponential base a to the x power. So you have a base a and a base a. You know what these two bases do? They cancel each other out. Boom, boom. Guess what the answer is? X. That's all it is. That's how easy it is. Okay? So if I go like this to you, which I will on a test, if I go log of, I'll just make it up 7, and I go 7 to the 3rd, what could you do right away? You can cross out the bases and put 3. But I hope it makes sense to you. 7 to the 3rd is equal to what? 7 to the 3rd. It makes sense, doesn't it? I hope. Okay. Then there's a part B to this, and that is, if you take a number a and you raise it to the log base a of x, you get
What is that for?
is that 4? Where's it 4?
What is
Oh, that's a, not that you're thinking that's a 4?
no?
No.
Is this
It's
number
part
4?
B.
Oh, it's 4. I'm sorry. It's like 3a, 3b. No one's saying the answer.
X.
Is it what? A? Okay.
X.
Or is it X?
It's X.
It's X? All right. Let's look at it. You know what I want to do? When things don't make sense to me, I always do this. I always put numbers in. I try to make it as easy as possible. You know what I'm going to do with that A? I'm going to say 5. Log base what? 5. And I'm going to put a number here that's really easy for me to figure it out. I'm going to put 25. Okay? So what you're doing is you're taking the number 5, you're raising it to what power? This power. But what is this number? Yeah, the log of 25 base 5 is 2. So this really says what? 5 squared. Oh, what's 5 squared? Hey, guess what? The answer is 25. So if I give you that problem, what's the answer? 25. Oh, well now I'll go back here. What's the answer? The answer is that. And here's why. Because these are inverse operations. This is an exponential problem. A to a power. That's exponential base A. This is logarithmic base A. Guess what you can do? Just like up here, what did I do? I can cross out the bases. What's the answer? It's that number. It's X. Here I did it here too, didn't I? I crossed out the A's. Log base A, exponential base A. Cross them out. The answer is what? X. That's all that property says. Now the fourth property says this. Fourth property is a 1-to-1 property, which you did in section 3.1. In section 3.1 I said if, let's say 5 to the x equals 5 to the 3x minus 4. If the bases are the same, what do we know about the exponents? They have to be equal. They have to be the same. Same thing here. Logarithm. If you have log of, let's see, what did I put here? Log base A of x equals log base A of y. What do you guys know now? If the bases are identical, those x's and y's have to be what? They have to be the same. Why? Because it says equal. So this and this must be the same. So you would say, I know x must equal y. Guess what? The next slide talks about the 1-to-1 property. Here's the 1-to-1 property. Do it again, except, tell me what x has to be here. They're actually solvable. Yeah? If the bases are the same, then you know this number and this number have to be the same number. Set them equal, solve it. Molly, what'd you get?
1/2.
She got a half. Yes, no?
Yep.
Okay, she's right. Can she check her answer? She can put it in half. What's a half plus 2? Oh, that's 2.5. Log of 2.5 leave base 2 equals what's half of 3? 1.5. Log of what? 2.5. Base 2. Log of 2.5. Base 2. We got it. It works. Okay. This next one, same thing. Base 3. Base 3. Set your numbers. This number equal to that number. Oh, I did that wrong. Sorry. That's a 4. And you get, Andrew, what'd you get?
5.
X equals what?
5.
Okay, Andrew says x equals 5. Or what? Or negative 5? How? You subtract the 4 and you get 25, right? Okay, x squared equals 25. You get this. You get what? Plus or minus 5. Did you check your answers? Did you put the 5 in? Did you put the negative 5 in? Do they both give you 29? Yeah, 5 squared is 25 plus 4, 29. What's negative 5 times negative 5? 25 plus 4, 29. It works. You okay? Being awfully quiet. All right. Here's how many slides are left? 2? 3? 3? Okay. This one says logarithmic bases that are most used. Okay. They're used so often, they give it this name. The common what? I just say common log. So what's the common log? The common log is this. Y equals log of x, where they don't even put the base down here. They never put the base. And if they don't put the base, you're supposed to assume you're in what? What base are you in? You are in base 10. When you see this in your book, they won't put a base. And you're going to go, well, what's the base? And the base is 10. Because they don't put it. And they don't put it, you're supposed to assume it. So they don't ever do this. They never do this. Okay? So look at that problem right there. What's log of 100? 2. Does that make sense? Okay, so let's try it. Base 10. 10 to the what? Second equals 100? Sure it does. Do me a favor. Because it's such a common base, they programmed it into your calculator. Would you just do this for me? Type it in. What's log of 100? Type it in. And you already know the answer, but I just want to make sure you get it. What are you getting?
2.
You're getting 2. Okay, do it again. Do log of, let's just do log of 1. 0? Okay, does that even make sense to you? Why? 10. Yeah, 10 to the 0 is 1. Okay, do this one. Log of negative 10. What? Domain error? Why? Do you remember the definition on slide 1? We have to take logs of what? Yeah, you can't take a log of a negative number. That was a trick. It's going to happen on a test. It's going to happen on a quiz. I'll tell you to do this, and you'll go, oh, the answer is -1 or negative. Well, you'll say something. No, there's what? No solution. There's no solution to negatives. You can't take the log of a negative. Okay? All right. Continue. Ready? This is called the common log. Guess what this one's called? The natural log. Well, the natural log, there's another number that is pretty common. It's not base 10, it's base what? Base E. But they don't put base E. They don't put base E. They just say natural log. And by the way, they go N natural log. Now remember, the natural exponential function was base E. Well, the natural log is still base E. So here's the deal. You're supposed to remember that your base is what in this? E. Okay, this is so common, they programmed it into your calculator. So find it. It's ln. It's not log, it's ln. Where is it? Is it under log? Okay, it's under log. Now, would you do me a favor and punch the natural log of 6? And it's not hard because the calculator is doing the work. 1.79. Okay. And by the way, that's an approximation. Does this make sense? Why it's 1.79? How do you know it's right? I know you guys are trusting your calculator. How do you know it's right? E to the 1.79 must be really close to what? E to this must be really close to 6. Punch it in. Don't always trust these answers. 5.99. Yeah, we're close, right? If you want to get closer, you just have to go farther up. You'd have to go a little further. Good? Hey, are you okay? Yeah? Do you need some water? Do we need to splash you with water?
No.
I thought you said the darkness was good. Or Katie, she's almost out. Okay? Ready. I think we're almost done, guys. We just have 2 slides up. This is us graphing. I don't really like this slide, but I'm going to do it anyways. It says the graph of a log function. There's a log function. I'm not going to read the rest of this to you because I'll read it to you and it won't make any sense because you haven't seen it. So here's what I want you to do. Take your calculator, okay, right here. I want you to do this. Would you graph this? Would you graph that? Would you graph this? This is exponential. This is logarithmic. This is linear. Okay, exponential, log, do it. One of them you can do without your calculator. Which one? Y equals X is linear. That should be an easy one. Kind of cheated. I just put it up there really quick. Everybody agree that's y equals x? Cross is at 0, that's the y-intercept. Slope of up 1 over 1, right? I agree. Where's the other one? Oh. All right, good enough? Okay, this is the exponential function. Anybody know, is that growth or decay? How'd you know it was growth? How'd you know it was growth? No. Base is greater than 1. If your base is greater than 1, you're going to grow. What number is that? 2.7. That's bigger than 1, guys. It's growth. What if your base is between 0 and 1? It's what? It's decay. Okay, so this is growth. Guess what? This function, because this is base E and this is ln, guess what? This is base what? E. Now when you graph this one, you got growth. It's right here. Here's your growth, right? Do you agree with that? That's what e to the x look like, right? E to the x is looking like this. The other one, ln, base e of x, this one, what did that look like? Tell me this. Look at your graph. See that point? That point happens to be 0, 1. On this graph over here, I think you can maybe see it. Isn't it 1, 0? Okay, tell me what this is. It's a what? It's a reflection over what? So guys, you see this? This here? This point? This point up here? You know what it's going to do? It's going to do this. Okay, then if you reflect the other side, if I reflected something like this point, it's going to be about right there. So tell me something about exponential functions and logarithmic functions. They're inverses, okay, because they're reflections over what? That's what we did in chapter 1. We did this. I don't know if you remember, but we did. Okay? So now, can I go back up there and talk to you a little bit about what it said now? Here it says, note the domain and the range. Okay? Well, we haven't done anything, so we better look at it. Let's come down. Let's look at the domain of your exponential one, e to the x. What was the domain? What was the range? Domain range. Look at this green one. Who wants to say the domain? All the x values, they got answers. All reals? Good. Okay. Who wants to say the range? All the y values that came out. Look, this y came out. This y came out. This y. All what?
Y is greater than 0.
Positive reals. Yes. All y's what?
Greater than 0.
Yes. What'd you say? Greater than 0. Okay. All y's greater than 0. There's different ways to say it, but that's what it is. You could say, maybe some of you want to say this. 0 to what? 0 to infinity, right? There's another way to say it. Okay. But now come over here and do this function. The other function was ln of x. This is the exponential function. This is the logarithmic function. What's the domain? What's the range?
Range is all real.
The range is what?
All real.
Oh, range? Okay, now you're looking at the blue, right? Okay, the range would be the y values. All y's. Well, what came out? Everything, right? Everything comes out. So you're right. All reals. What about the domain? Only x's that are what? Greater than 0. So you guys tell me something about the domain and the range of an exponential versus a log? You say they're opposites. Do you guys remember when we did inverses? We took the x's and the y's and did what? Did we flip them? Okay, guess what? The domain of the exponential function becomes what? The range of the logarithmic function. The range of the exponential becomes the domain of the logarithm. They get switched, and that's what you're supposed to note. Okay. See, I couldn't read it to you in the beginning because you didn't even know what I was talking about. Also, did you notice this? X equals 0 is a what? Did you guys notice this runs into what? A vertical asymptote of what? X equals 0. Did you notice that? Oh, good. Did you also notice this? This is weird, but it's true every time. Your logarithmic function passes through what point? 1, 0. And what other point? A1. What's this A? A is your, let me go back up there. Right here. A is your what? Your base. Whatever your base is, you're going to go through that point. Do you guys know what your base is right here? What's your base in this problem? So you're going to go through what point? E comma what? E comma 1. What other point? Always this point, 1, 0. And did I go through these points? Yeah, I did. Here's 1, 0. And here's E. E is like about here. And then here's 1. E1. That's really all it is. Okay. Now, one last problem, and that's this. Would you graph this right here? This is not easy to graph. So here's what I'm going to tell you. Start with this. Start with your parent, and then do your transformations. But what's your parent? That's a log problem. So your log parent will be log of, you probably want your base. What's your base? 3. And to make it really simple, this is your parent. Just call log of what? Every time. You just say log of x, base 3. And then here is your function f of x over here. Okay? Now, here comes my question. How do you graph a log equation? What? Okay, so Brandon said something. He went too far. I was hoping Brandon would say, you don't graph a log function. Then, Brandon, you were going to say, change it to exponential. He's basically saying, don't do this. Don't graph a log function, graph what? Exponential. Oh, if I want to do that, I better change that function to look exponential. Exponentially, this function would be what? 3 to the what?
Y.
3 to the y equals what?
X.
X. That's what you want to graph. Do not graph log functions. They are ugly and they're tough, and I do not recommend doing it. Go back to exponential because it's the same thing. Okay, so here we go. You can get easy points. Ready? Here's a trick here. The trick is when you plug numbers in, what's the trick? What?
You do Y.
Yeah, don't go with x's because if you do x's, it gets really weird. Start here. Start with your y's. So an easy number to put in for y is 0. Probably 1. Probably 2, right? Do it. Help. 3 to the 0. 3 to the first. 3 to the second. Okay, we're done. Now move on. No, gotta get off these positives. Let's go negatives. Okay? 3 to the negative 1. 3 to the negative 2. Okay. I have to move my graph over a little bit before I start this because it's a weird graph. Okay, I'm ready. Well, hopefully you're ready. Graph them. You get ahead of me. Yeah? Are you okay with what I did so far? I did 1, 0, 3, 1, 9, 2. I did the easy ones. I said, I want this, I want this, I want this. Those are easy. Okay, these two, not the easiest to graph. How do you graph 1/3 comma negative 1? Over how far? 1/3 down how far? Okay. 1/9, negative 2 would be over a 9th, down 2. See it? What's it going to do if I keep going? It's going to run straight down the y-axis. That's known as your vertical asymptote of x equals 0. That's the graph of who? The parent. You're not done. You thought you were done? You're not done. What does this say to you?
Right forward, left hand.
Right 4. Right 4. And then what?
Stretch factory.
Okay, stretch. What kind of stretch? Vertical stretch by what? Stretch by 2. And when I say vertical, what are you multiplying by 2? The x's or the y's? The y's. So you take the y values and you take them and multiply by 2. Okay, here we go. Ready? Where does 1, 0 go? Okay, guys.
5, right forward.
Okay, so you're at 5, aren't you? Okay, now what's the y value right where my pen is?
2.
Multiply 0 by 2.
0.
Oh, you didn't even go up. There's no stretch going on because you were on the x-axis. You can't go any higher. You were at 0. Okay, this one. 1, 2, 3, 4. I'm at 7. But I'm up 1. Stretch it by 2. Go up, what? 2. Right here. This one. 1, 2, 3, 4. I'm at 13 now. 13, 2. Stretch it by 2. 4. I see this. Going that way. Oh, we're almost done. I need to know this. What happened to the vertical asymptote?
Over 4.
X equals 0 turns out to be x equals what?
4.
X equals 4 now. Go down. There it goes. Yeah? Hey, does it help you to see the parent?
Yes.
It does me. People ask me, should I put the parent on paper? I kind of do, because I like to know what points am I moving right for and stretching. I like to know what I'm doing. Some of you might be that